Welcome. Today we start a new lecture series uh, to solve problems for different competitive exams like JEE Main, JEE Advanced or different state level joint entrance examination. So initially we discuss chapter wise. All chapters will be taken up one by one. In each chapter, except for few basic formula, all important formula will be discussed here. Uh, all important formula and important tips to solve the problem in shortcut method. All type of problems from easy to harder will be solved here. First of all, today we take the chapter progression. It includes arithmetic progression, geometric progression, and harmonic progression. Let us discuss few important formula for AP first. Arithmetic progression. Number one, if A1, A2 up to AN are in AP, then A1 plus K, A2 plus K up to AN plus K, that is, if a constant term is added to each of the terms in AP, then the resultant series will be again in AP. And its common difference will be same like that. That is, this minus that is A2 minus A1, like this. Similarly, if a constant term is multiplied with each term of that, that is A1k, A2k up to ANK, k is multiplied with each term of that, then the resultant series is again in AP. Here, the common difference of the new series, it will be A2k minus A1k, that is A2 minus A1 into k. So, common difference will be changed for that case. Okay, next to discuss if A and L be the first term and last term of an AP, then Sn, sum up to first n terms, it is equal to n by 2 into A plus L, and that is equal to n by 2 into 2A plus n minus 1 into D. Obviously, A is the first term, L is the last term, and D is the common difference of the series. Next, Tn, nth term, it is equal to Sn plus 1 minus Sn, and it is valid for all n greater than or equal to 2. uh, rather it is Sn minus Sn minus 1. So next, if x is 1, arithmetic mean between a and b, then x is equal to a plus b divided by 2. Arithmetic mean, I think you know it. Actually, it is nothing but if between a and b one arithmetic mean x is introduced, then these three a, x and b, they will form an AP. If more than one is introduced here, say x1, x2 and so on, then a, x1, x2, xb, they will form a AP. This is meaning of arithmetic mean. So if one is introduced between a and b, x, then that mean is a plus b by 2, mean of these two. So next, if x1, x2 up to xn, these n arithmetic means are introduced between a and b, then how to obtain the values of x1, x2 up to xn? Clearly here a, x1, x2 up to xn and b, these are means introduced between A and B, then they together will form an AP, an AP. That AP contains n plus 2 terms, 1, 2 and these n plus 2 terms. Suppose this is the common difference, then common difference D will be equal to b minus a divided by n plus 1, because of the fact that this AP has n plus 2 terms. First term is A, last term is B. So that B is equal to A plus n minus 1 into D. From here, D can be calculated like that. Now, knowing D from this formula, all arithmetic means, their sum, etc. can be obtained. Sum of the arithmetic means, most of the times problems are given from there. Sum of arithmetic means without lot of calculation, without calculating x1, x2, etc. by using that, it is not necessary. I am giving you two important formula. Sum of, for a series in AP, sum of two, just one property I mentioned first. Suppose this is an AP. So for a series in AP, sum of two equidistant terms, one from the beginning and one from the end, equidistant terms, means suppose this and that, it is one term after beginning and this is one term before end. Their sum is always equal. That is, A plus B is equal to x1 plus xn is equal to x2 plus this one, x2 plus xn minus 1, etc. They are all equal. This is very important property. and sum of n arithmetic means between a and b will be equal to n into a plus b by 2 by using that property. This is very important formula. Sum of n arithmetic means introduced between a and b is equal to n into a plus b by 2. Without calculating the arithmetic means, the result can be obtained by using that formula. So next, the sum of AP containing two n terms is equal to sum of an AP containing two n terms is equal to n into T1 plus T2n, and sum of AP containing 2n minus 1 terms. This is for 2n terms. This is will be equal to 2n minus 1 into midterm, middle of the term, midterm. And this thing, I think sigma of r is equal to 1 to n is equal to n into n plus 1 by 2. R is a integer and it 1 plus 2, this means 1 plus 2 plus 3 up to n, and sum is that. Similarly, sigma r square, r is equal to 1 to n, it is equal to n into n plus 1 into 2n plus 1 by 6, and sigma of r cube, r is equal to 1 to n, it is equal to square of that. That is n into n plus 1 by 2 whole square. I discuss few formula and property of arithmetic progression. Next time I will tell you the formula and properties of geometric progression, harmonic progression, etc. And today let us solve few problems. The first problem is question number 1. If sigma r is equal to 1 to n is equal to 136, the value of sigma r square, r is equal to 1 to that n, how much? Options are 1200, second option is 1496, third option is 1428, and fourth option is 1402. Actually, this is a very simple problem, r is equal to 1 to n, it means n into n plus 1 by 2 is equal to 136. Actually, it is a quadratic in n. Very easily you can solve it. N into n plus 1 is equal to 2 272. This into that. It is a quadratic in n, quadratic equation in n. We can solve it. But uh, no need of solving that. Actually, it is, you see, it is product of two integers, product of two consecutive integers. One, if one is n and one is one more than n. So try to factorize it. 272 to 136, then 2 68, then 2, this is 34, this is 2 17. No other factor is possible. You see, this uh, this is actually equal to 16 into 17. Mentally, I think this can be calculated, 16 into 17. So we get n is equal to 16 and 17 is n plus 1. So n is 16. So our answer is sigma r square. R is equal to 1 to n is 16. That is, it is equal to n into n plus 1, formula is n plus 1, into 2n plus 1, that is 33, divided by 6. Just now I discussed that problem, that formula. It is 11, 3. This is 2, this is 8. So that 8 into 17 into 11. And very easily you can calculate that. And I think answer will be 1496, this one. So without factorizing it, you always try to uh, take the advantage that it is a product of two consecutive integers. In so many problems, you will get that n into next higher integer. So try to factorize it in such a manner that it is two product of two consecutive integers. Mentally, I think mentally, most of the times, mentally it can be, you can do that. So knowing n, very easily you can find the value of that. It will save some time. Now our next problem. Number 2, problem number 2. If 11 means are introduced between 4 and 40, then sum of the arithmetic means, actually, as options, 238, 302, 284, and 242. Let us see what is the problem. Two given numbers 4 and 40 are there, and 11 arithmetic means are introduced. Suppose this is x1, x2 up to x11. So they together form an AP. To find the sum of the arithmetic means to find the value of that. Very easily we can find the common difference of the series, and after finding common difference, x1, x2 up to x11 can be solved, can be obtained, and then add them. But using the formula, you know that I just now I discussed it is equal to n by 2 into a plus b. It is the answer. N means number of arithmetic means introduced. So it is equal to 11 by 2. N is 11 by 2 into 44. So that 11 into 22. So that it is 242. So 242 is answer. So knowing this very simple tricks, uh, you can save your time. Next problem. If problem number 3. If ratio of sums of n terms of two different APs is n square plus n plus 1 is to n square minus n plus 1, then find the ratio of their fifth term. So now let us see what is the exact problem. Two different APs are given and sum of first n terms of first series and sum of n terms of the second series, and their ratio is that. So actually we are given first series is Sn and second series is S dash 10, and that is equal to that. Suppose for solving problem, suppose A is the first term and D is the common difference of the series, first series, and A is capital A and capital D are the first term and common difference of the second series. So as per condition, ratio of sums of n terms is this and that. That is, we must get n by 2 into 2a plus n minus 1 into d by n by 2 into 2a, 2 capital A for the second series, n minus 1 into capital D is equal to n square plus n plus 1 by n square minus n plus 1. Now we have to find the ratio of their fifth terms. So T5 of the first series by T5 of the second series. Now T5 actually is equal to A plus n minus 1, that is 4D for the first series, and A plus 4D capital D for the second series. We have to find this ratio. Now here clearly these two terms cancels. So 2a plus n minus 1d, and same here. So T5 is a plus 4d. It is 2a. If I somehow by using some particular value of a n, if I can find that this is equal to 8d, this is 8d, 2a plus 8d, 2 can be taken common, a plus 4d. So for that purpose, you suggest n minus 1 is equal to 8, so that n is equal to 9. Put n is equal to 9 over there, and it is the identity. So putting n is equal to 9 over in left hand side and right hand side, equality will be held. So that it is equal to 2a plus 8d by 2a plus 8d is equal to, n is equal to 9, mind that. It is equal to 9 square plus 9 plus 1 by 9 square minus 9 plus 1. So 2 cancels. So T5 and T dash 5, after cancelling 4 from here, A plus 4D T5 is equal to 81, 91. And here it is it is equal to 81, 82, 82 minus 9. So it is equal to 373. So our answer is 91 is to 73. Oh, I have forgotten to give the options. It will be 91 is to 73. Yes, okay. Let us stop today. From tomorrow, next day, I will discuss more problems on that. So if you think that it will help you, you please like my video, like, share, and subscribe my video. Thank you.